Hi, this video we're gonna look into stress. Okay. So, stress we learned about it is force over area. Then for SI unit, force will be Newton per area will be meter square. So what's Newton per meter square? Pascal. And also for US system, pound force will be the force unit, area will be square foot. So that's another way we call PSF, pound per square foot. But often we use pound per square inch or call it PSI, right? So how is this related to internal loading or load shear bending diagram we had spent a lot of time on earlier on? So internal loading allow us to find at any point or specific point, load shear bending diagram, all of those. Any specific point, what's their normal shear or bending, right? Then how do we use that information? We're going to use that to find our internal stress. In order to do that, we're going to use the force over area for internal stress. So let's take a look. And for example, the first thing is going to be our normal stress. Normal stress have this symbol, is called a sigma, and that is going to be your internal loading you find out from here, divided by area. And be aware, normal stress, normal force is the force that's perpendicular to the cross-section area. Then the second stress is going to be shear stress. It's going to be parallel to the surface because the shear force is basically parallel or on the surface. And that has a symbol of tau. Tau is equal to V over A. V is our internal shear. You learned in internal loading. So those are the basic concept of stress, normal stress, and shear stress. And another thing worth looking into is a little bit more discussion on the units. We talked about just now, Pascal is Newton per meter square. So now I want to impose a question to you. What is going to be Newton per millimeter square, right? So we learned 1 meter is 1,000 millimeter. So 1 millimeter, let's do a unit conversion. And we want to get rid of millimeters. So this is going to be at the bottom. And 1 meter is 1,000 millimeter. And this whole thing have to be have to be power of 2. Then you cancel out. What do we get? We got Newton meter square and 10 to the 3 and then power of 2. That would be 10 to the power of 6. Then flip it up, 10 to the power of 6 Newton per meter square. That will give us 10 to the power of 6 Pascal, because Newton per meter squared is Pascal. And what's 10 to the power of 6? Mega. So that's megapascal. This comes really handy. That means when you have a problem, you find the internal force in a unit of Newton, the cross-section area is millimeter square, then immediately when you're trying to calculate the internal stress, that gives us megapascal. Okay, so another quick one. How about if it's kilonewton per millimeter square? So the only thing that's different is this kilo, right? And the rest, it's the same. You all have Newton per millimeter square, Newton per millimeter square. You already know Newton millimeter square it's megapascal. So what is kilo times megapascal? So that's 1,000 times megapascal. That's right. They're going to give us gigapascal because 1 giga is equal to 1,000 megapascal. Okay, so that's another important unit. In other words, if you calculate the internal force as a unit of kilonewton and cross-section area is millimeter square, immediately you know this internal stress is going to carry on the unit of gigapascal. Having this information available, it's really helpful when you're solving it. So you don't need to do this unit conversion every single time again. All right. So that's our quick concept preview about stress. So in the next video, we're going to look at some example. Okay, bye now.